Good afternoon.
Okay, today we will see about the conductometric titration for the mixture of acids. Okay. So what is acid-base titration? What will happen when an acid is titrated against a base? What type of reaction? Neutralized. So the reaction is called neutralization reaction. Okay, in this, the empathy part is we are going to find out the amount of the acid that is present. Okay, for that we are using the conductometric titration. Okay, here you have a solution, mixture of acid solution is taken in the speaker. We have two different acids. One is hydrochloric acid and acetic acid. What type of acid is hydrochloric acid?
Strong acid.
Okay, how do you say it's a strong acid? Because it gets completely dissociated in the solution. Okay, so it's a strong acid. What type of acid is acetic acid?
Weak acid.
Weak acid. Why do you say it's a weak acid?
Because it gets partially dissociated.
Okay, very good. Because it gets partially dissociated in solution. Okay. So now we are going to find the strength of this strong acid and weak acid using the conductometric titration. In your conventional method, that is in the volumetric analysis, how do you do the acid-base titration? You are adding indicator. Okay, you are having the acid base and you add the indicator. What indicator you are adding over there?
Phenolphthalein.
Phenolphthalein. Very good. Okay. So by changing the color, you find the end point. Okay. So why do you use a meter, a digital instrument over here? Yeah, to get accurate results, we are using a digital meter. Okay. Now I have taken 20 ml of mixture of acid in this beaker, added 20 ml of distilled water. Okay, only now this is a electrode that is dipped into this. Okay, this is the conductivity cell. Here the potential difference is developed between this, and there is a value over here. The value in the conductometer is a digital value we are getting. Why do we get a value over here? Because
it decreases.
you get the value over here due to the movement of
H
H plus ion. Okay, there is movement of H plus ion in this solution. Due to that, this is a conductivity cell. It gives you the value. Okay, now I am going to. This is a sodium hydroxide. Okay, it's a strong base. Okay, now we are going to titrate this with these strong base. Okay. Okay, when I am going to titrate, see I have set the temperature, the conductance cell constant and the range, everything is set in this apparatus. Now we are going to titrate. Okay, now I will add 1 ml of the base into the solution. Okay. Now what do you think? What do you think the value will be over here? The conductance value, what will happen to the conductance value?
It decreases.
It decreases. Why it is decreased?
Because movement of H plus ions.
Yeah, movement of H plus ion, it decreases because it is getting neutralized. Okay, so see, you can see the value, it is getting decreased. Note down the value. For the volume 0 ml, you have a value, and we are adding 1 ml. Now the conductance value is getting decreased. Okay, so you should repeat by doing like 1 ml of the base I am adding, and I am stirring the solution, and I am waiting for the reading to be noted. Come here and show the decreasing value. See, now the value you are having, you have noted this. Now I am adding sodium hydroxide and I am stirring the solution. The conductance value is again decreasing. Okay, note the value. Okay, so you are having the decreasing value. So I am going to take the readings. Okay, you have to take the readings. Okay, first what will happen? The base, it reacts with the acid. First the neutralization of HCl is done. Because it is a strong acid, first that is neutralized. Okay. Then after that, the end point, there will be increase in the value of the conductance value of the solution. You will get an increasing value. That is because due to the formation of sodium acetate ions. Okay. Due to that, there is a conductance and there is a slight increase. and after that end point that is neutralized, you will have a sudden increase in the value of the conductance. Okay, that is due to the presence of excess of OH minus ion. After all the reaction is over, there will be, you are adding the base solution. Okay, so there will be excess of OH minus ion that is present in the solution. Due to that, there is increase in the conductance due to the movement of OH minus ion. Okay, so this is about the conductometric titration of mixture of acid. You have to plot a graph by taking volume of the sodium hydroxide along the x-axis and conductance value along the y-axis. Okay, you will first get a decreasing value, then slight increase and sudden increase. You have to join all the maximum points that is coming in line. You have to intersect it and find the volume of the neutralization point for strong acid and the weak acid. From there you have to do the calculation using the volumetric that is method V1 N1 is equal to V2 N2. Okay students, thank you students.
Thank you.